everyone. Welcome to this plenary panel on evidence of how incorporating gender considerations into science and technology informs policy. I also rather to keep listening to the astronaut. She was such a wonderful speaker, but we better start with our session, which is also very interesting. We have three very distinguished speakers, and let's get started. I am very glad to be here. I was invited by the Mexican Council for Science and Technology. That's why the label of CONACYT is close to my name. I work for the National University of Mexico, but I was invited. That's my only relationship with them. And let me introduce myself. I am a molecular parasitologist. We recently published the genomes of 4 tapeworm parasites. This is my area of interest, but perhaps the invitation to my person is due to the fact that I was president of the Mexican Academy of Sciences a few years ago, and I was also elected co-president of the Interamerican network of Academies of Sciences. When I received the invitation, I thought I couldn't give this opportunity to talk about IANAS, the Interamerican Network of Academies, because it has a lot to do with the discussion these days here. And so, as I said, IANAS is the network of the National Academies of Sciences in the continent, which means that all of the academies in the continents are affiliated to IANAS. If you want to work, to collaborate with any of the academies, come to IANAS. They're willing to help you. So our strength are the 23 academies in the continent. Let me tell you that not every country has a national academy, because the communities are too small in some of the countries, because they're not so well organized. But any functioning academy is working with IANAS. And IANAS is affiliated to the World Network of Academies that is called the Inter-Academy Panel. The Inter-Academy Panel brings together all the national academies of science in the world. So I could let you know the message I'm going to give you here. And when thinking about gender issues, look south. Look south. Don't forget. Okay, the mission of IANAS is to bring together the efforts of the different national academies, and in order to promote collaboration, and in order to transform them into independent actors providing advice to their respective governments. And the way IANAS works is through the organization of programs. We have 5 functioning programs. And I'm going to talk about the program Women for Science, but let me tell you just a few words on the other 4 programs. The first program is capacity building, which means to help each other. You know, the National Academy of Sciences, the Royal Society of such strong organization, but this is not the same for Honduras or Salvador or Peru or Bolivia. So the idea of this capacity building is to collaborate, to join efforts, to help each other. Then the second program is the science education. Maybe you know that science education is not in very good conditions in our continent, and particularly in the southern countries. And this is a very important problem for the future development of our countries. So we are putting the effort on improving the quality of science education in elementary schools. The scientists are helping the teachers to improve the quality of and this program is working in 18 different countries of the continent. The energy program. Oil is becoming more and more scarce, and we need to make the transformation into more sustainable ways of energy production, and that's the idea of this. We already produce a diagnosis for the energy situation in many countries, in most of the countries of the continent. The water, the same situation. Water is going to be a very, very valuable resource in the future. And then we come to the Women for Science, one of our very recent programs. It has been working for 4 years now. We have 2 co-chairs, as in the case of the rest of the programs. One of the co-chairs is from the United States, Anneke Lebel-Sengers, and the second co-chair is from Cuba, Lilian Alvarez. And the vision of our Women for Science program is full inclusion and empowerment of women in science and technology. That simple. And you could imagine that the situation of the women scientists in many countries is similar to the situation you have in the States or in Canada. Although in certain areas, the numeric difference can be small, but when you climb up to the upper levels, to the decision-making levels, the number of women scientists is very much reduced. So we are trying to empower women within the academies. How are we doing this? We are organizing groups. We are appointing focal points on each academy. We already have organized groups working on this kind of issues in every of the national academies that I mentioned before. And with the support of the academies, we are working on addressing gender issues. We are advising on these groups the way the major issues they should approach, and we are producing quantitative and qualitative information, reliable information on the situation, academic situation in the southern countries of the American continent. And for example, you can look at our homepage, YANAS, just type YANAS and you're gonna find it. And many issues under discussion are there. Another strategy is what we call the spread out the information, and we have different lines of work. One of them is to collect very inspiring biographies and to publish them in order to attract the attention of the decision makers, and also in order to attract the attention of the little girls and the little boys, because some of these stories we have collected are really amazing. I'm going to show you a little more. And then we have this prize in order to support young women scientists from these countries. We just published this book. You can get a PDF of the book in our portal. It's very enjoyable, very enjoyable. The stories of the effort some women scientists have done at home and in the academy is really touching. And we also promote the presence of these leading scientists in the media. This is happening almost every day. This is just an example that appear on BBC World, and we are informing about the stories of the L'Oreal awardees, which is a very important recognition in the biological sciences, and this is the last awardee of our prize. And then, just to give the room to the next speakers, our next steps are strengthening the existing regional committees, performing or finishing the detailed census on the women's, and finding other ways to gain recognition to these outstanding women scientists. So my message is, when looking south, Llanas can be a partner for you. Llanas is the best organized academy organization in the continent. We have a gender program already working, and we have very active networks working in every country of the continent, and these are the contacts, so you can reach our organization whenever you want. And having said that, I'm going to pass the microphone to our first distinguished speaker. Sabra Klein is an assistant professor of the Johns Hopkins University. She tells me that her laboratory is not in the subway station close to here, but it's 35 miles from here. She works at the Bloomberg School of Public Health in molecular microbiology and immunology, and she's a leading expert on sex differences in susceptibility to infection. In 2010, Dr. Klein won the award for science contributions of the Society for Women Health Research. Welcome. Go ahead.
Familiar. So thank you. I want to thank the organizers for inviting me to this just enlightening meeting. It's been wonderful learning and having such a deep discussion about gender. And I would now like to change gears and talk a bit about sex and talk about our biological differences and how this results in differences in our responses to vaccinations, and talk a bit about how I think this needs to start shaping policy and recommendations. So let's begin with death. So it turns out both men and women die. The good news for many of us in the room is that you have more men dying than women, so nothing too surprising there. Here we're looking at the causes of global death. These were data that were analyzed from 2010. And what I found really interesting about this analysis is it focused on a population that we often do not focus on when thinking about causes of death. Individuals in their, if you will, reproductive years, ages 15 to 49. And so worldwide, the leading causes of death for women in order are HIV/AIDS, cardiovascular disease, tuberculosis, and reproductive cancers. Okay, again, in this age group. For men, the leading causes of death in order are cardiovascular disease, road traffic accidents, HIV/AIDS. And so joining you from a microbiology department where I think pathogens, viruses, molecular parasitology is very interesting. When I see these data, what I see is that the role that infectious diseases play in contributing to global death rates is different for men and women, and this is often overlooked. And it turns out that across lots of different pathogens, and I work with viruses, so you're going to see a distinct bias toward viruses throughout my discussion. I don't know what we would call that kind of bias. But it is not that there's something remarkably unique in terms of sex and gender with regard to viruses. We see these types of differences with regard to bacteria and parasites and allergens, and I could go on and on. But so sticking with viruses, what I have here are just a list of several different viruses, many of which you've heard of, others of which maybe you haven't. These are all data in humans, and they make the point that males and females differ. And across very diverse species of viruses, we typically find that the intensity and prevalence of infections are often higher for men as compared with women, and that despite this difference in the intensity and prevalence, when we look at severe disease, so disease resulting in hospitalization, or when we look at mortality, HIV is a great example, influenza, which is what I work with, and you'll see that bias throughout my talk. When you look at disease resulting in hospitalization and death, we often find this to be higher in women as compared with men. And this likely reflects complex interactions between gender and sex. And again, today I want to focus a bit more on the biology, and I want to focus on our biological responses to vaccines that are being developed to protect us against many of these worldwide infectious diseases. So let's start with our immune system. This cartoon, again, I'm biased to my viruses, but this could be day after exposure to anything foreign to our immune system. And we're looking at the magnitude of the response. And for the non-immunologists in the room, I will keep the jargon to a minimum. When we get exposed to anything, whether it is a virus or it's a vaccine, what we typically find is that the immune cells of females more readily recognize and respond to the presence of something foreign as compared with males. So this starts right away. This starts within moments after our immune system initially recognizes something foreign in our body, and it takes off from there. These immune cells then make proteins that are going to initiate other cells to come to the site of infection or vaccination, and you're going to get greater proliferation, division of cells, activation of cells, production of all kinds of effector responses, the army of cells and responses that are absolutely necessary for protecting us against infectious diseases are consistently higher for females as compared with males. So this is all great. This means we tend to clear infections faster, more efficiently than our male counterparts. Where problems ensue is that you can't have your immune system activated forever. Okay, at some point you need the inflammation and these immune responses to become down-regulated so that your immune system can return to some level of homeostasis. And we have all kinds of regulatory types of responses in place to bring down or dampen these immune responses. But what often happens is that the dampening of these immune responses isn't as effective in females as compared with males. So this return to baseline can take longer for our females as compared with males. And what this can lead to is in females a risk of what we like to term immunopathology, and all that long unfortunate word means is that tissue damage being caused by activation of our immune system. That inflammation that, if unregulated, can actually damage tissue is a much greater risk for females as compared with males. Conversely, as males initiate these regulatory responses or these anti-inflammatory responses quite efficiently, this can lead to a reduction in these effector responses too quickly, leading to a risk of viral persistence. Okay, so it's not that we have different immune systems in place, recognizing vaccine antigens or recognizing viruses. We have the exact same immune system with the exact same cells and proteins and pathways in place to protect us. But for reasons that we are still trying to uncover, we respond very differently, and the activation of these responses differ dramatically between males and females. And so what I want to talk about just for a moment is that this results in differences in the outcome of infection. And so I'll pick up the pace through here so I don't have to rush through what I'm really here to speak about. But given the role that our Canadian colleagues are playing in hosting this meeting, I wanted to just point out some data from the 2009 H1N1 pandemic, where Canada, in part because of their very efficient women's health network and this concept of analyzing epidemiological and clinical data through what they've termed a gender lens, during this pandemic, they were a standout country for actually analyzing data broken down by males and females and reporting whether or not differences were observed. So during this most recent pandemic, we heard a lot about individuals of reproductive ages being at greater risk of developing more severe disease and being hospitalized. We heard a lot about pregnant women. We heard a lot about comorbidities like obesity, heart disease. But what failed to make it into the media in any real way, at least here in the United States, was that it turned out that just being female, regardless of whether you were pregnant, was in fact a risk factor for being hospitalized with severe disease during this pandemic. And I think this just points out how overlooked, but yet clinically important, these types of observations can be. And so just to make the point and put a plug in for my lab, this is precisely what we do. We study male-female differences and the causes for these types of differences in morbidity and mortality following infection, as well as vaccination. And so I will just leave it at that and switch to what I'm really here to talk with you about today, and that not only do we differ in our responses to infection, but we differ in the treatments that we've designed to, in effort, protect us against these infectious diseases. And again, I'm showing my bias for viruses. Here we have a vaccine for influenza, measles, mumps, rubella, hepatitis, herpes, yellow fever, human papilloma, HIV, and then the rest we can read. 2 points I want to make with you from these data, and these are all published data. When we look at what we call the humoral immune response, so this is just the production of antibody, which for most vaccines is considered the best relative correlate of protection that we have for a vaccine. This, through clinical trials, is what we use to determine whether a vaccine is going to provide sufficient protection within a population. And for the studies that have reported statistically comparing males and females, what you can see is that consistently this relative correlate of protection, the production of antibody, is consistently higher, significantly higher for females as compared with males. So that's a good thing. We're going to be better protected. The downside of what the data suggest is that when we look at adverse reactions, and for some vaccines, like the influenza vaccine, this can be very minor, and we're going to go through examples of that. For other vaccines, like the yellow fever vaccine, these side effects can actually be quite severe. And so where these adverse reactions have been reported, again, we consistently find that the adverse reactions are higher for females as compared with males. So I thought we would start with just something that's a bit shocking and a bit controversial in the vaccine literature, that childhood mortality following vaccination in developing countries is higher among girls. So in the late 1980s, the WHO introduced what was referred to as the high-titer measles vaccine. So it's this EZ, this Edmondson-Zagreb high-titer measles vaccine. And what this vaccine was introduced to do was to provide protection to infants during a time of increased susceptibility to measles, when a mother's maternal antibody has waned, so roughly at 4 months of age, to 9 months of age, which is when the standard measles vaccine is administered. They initiated several trials in regions of Africa, including Guinea-Bissau. And so these are data from Guinea-Bissau collected from 1986 to 1990. And we're looking at survival. So these are epidemiological data looking at over time, survival rates for males in M, at females in Fs. Control were children who just received the polio vaccine. EZ are children that received this high-titer measles vaccine. And what was reported by colleagues in Denmark who work in this region was that survival rates were significantly reduced in girls who received the high-titer measles vaccine. As a result of this, the high-titer measles vaccine was pulled off the market, and to this day, it is not administered. There is considerable research effort being put into the design of an improved measles vaccine. This is why it was pulled, but it really wasn't discussed that this effect was specific for girls. These investigators, after the measles vaccine was blamed, they went on to look at, well, what else are children getting vaccinated with? And is it fair that we're blaming all of this on the measles vaccine, or could it have something more to do with the scheduling of vaccines? So here are their data of children who only received the high-titered measles vaccine, girls stereotypically in pink, boys in blue. Here we're looking at numbers of deaths in several regions. And so here's our Guinea-Bissau data where you see there were no deaths. And when they looked across the various regions in Africa where the high-titered measles vaccine was introduced, they found that in children that only received the measles vaccine, there was really no male-female difference in the ratio of death. They only saw male-female differences in children that not only received the high-titered measles vaccines, but in children who received the diphtheria, tetanus, pertussis vaccine, as well as the inactivated polio vaccine. So it was this combination that seemed to increase the female-to-male mortality ratio twofold for females as compared with males. Again, something that's not often discussed, and the extent to which this is being caused by biological differences or gender differences remains controversial, but I think this makes the point. There are male-female differences, and we still are uncertain as to why. Again, I am interested in biology, so let's talk about a little bit of biology. Inflammatory responses to vaccines are higher in women as compared with males. There's been an ongoing interest in vaccinology in trying to better predict the outcome of vaccination and the efficacy of vaccines. And so one path that's been pursued quite heavily for vaccines is, are there certain pathways that get activated by our immune system immediately after vaccination? So maybe within the first 72 hours after we get vaccinated, that we could then use to predict long-term protection. And so a lot of high-profile papers have come out with a lot of fancy genomic data. And so you're looking at one of these fancy genomic pathways, Red is significant upregulation along this fancy pathway. Green is significant downregulation along this fancy pathway. And the take-home message from a lot of data and a lot of authors on these papers was that activity along inflammatory pathways predict long-term protection. Well, all these multi-million-dollar studies were conducted not considering the sex of the volunteers. So we acquired their data, we reanalyzed their data and told them that we were doing this. And we don't have quite the fancy graphics that they do, but here we have the same pathway. Okay, the same inflammatory pathway that they said predicts protection. All we did was a two-way ANOVA instead of a one-way ANOVA with the sex of the volunteer as one of the variables. The exact same pathway populated with data from female volunteers or from male volunteers. Again, red is significant upregulation, green is significant downregulation. And the take-home that I want, since I know you can't read a single symbol in there, is that activity along this pathway is significantly higher among females as compared with males. And if the conclusion of all these fancy papers was that this predicts protection, then this might suggest that females would be better protected than males. Okay, antibody responses. So let me skip over that. So let's talk about influenza, since that's where my love is. When we look at inflammation following receipt of the trivalent inactivated vaccine, so that's the one we receive intramuscularly, what we find is that when we look at the size of a reaction for females in pink, males in blue, whether we're talking about young adults or older adults, 65 years and older, what we consistently find is that the inflammatory reaction, that local pain and swelling that occurs following vaccination, it really is greater for females as compared with males. When we look at those antibody responses, so the correlate of protection, what we find in females, these are data from women 18 to 49 years of age, whether in response to a full dose or in this clinical trial, they even tried a half dose of the vaccine, consistently find that antibody responses are significantly higher for females as compared with males. And again, the reporting of injection site pain, inflammation, muscle pain, headache, all relatively mild, but yet unpleasant adverse reactions are consistently higher for females as compared with males. The prevailing hypothesis is a gender-related hypothesis, that women just are more likely to report these adverse reactions. I've literally had people tell me women just may be more likely to complain, which maybe it's a hypothesis, but I would also like to emphasize that from the perspective of a biologist, if our inflammatory responses really are higher, it just may be that we really are experiencing significantly more inflammation and therefore pain associated with inflammation, as compared with our male counterparts. Just to emphasize that we see these exact same differences not only among 18 to 49-year-olds, but among individuals 65 years and older. We find that women have higher antibody responses and are experiencing significantly more adverse reactions, not only to the standard dose, but even the newer high-dose influenza vaccine that was introduced 2 years ago. This led to me working with Phyllis Greenberger, who's the president of the Society for Women's Health Research. So during the 2009 H1N1 pandemic, we proposed that maybe during times of pandemics and times where we have concerns about vaccine shortages, you might be able to give females a lower dose, have more vaccine to distribute, and women then might experience fewer of these adverse reactions. And we'll come back to this in terms of recommendations. Again, just a plug, we can recreate this in our animal models, which really allow us to then show that we see the same types of sex differences, with females having higher responses, immune responses to vaccination as compared with males. What we can do then in our animals is we can then challenge them with pandemic strains of virus, with lethal doses of virus, and we can actually show that females are better protected. So we do have, evidence to speak to that. A public health message, when we look at acceptance of vaccines for flu, we find that regardless of whether we break this down by age, as I've done here, whether we're talking about in the United States, in Europe, in Asia, in healthcare providers, it doesn't matter how we slice these data, fairly consistently we find that acceptance of vaccines are lower for females as compared with males. Lastly, I just want to end making the point that vaccine efficacy has been shown to be different for males and females and has resulted in an inability to get some vaccines out to the public. And so this was a phase 3 clinical trial that ended with no overall efficacy for a herpes vaccine. Okay, so this is just a herpes vaccine. Here we're looking at data in all subjects, which is how most vaccine clinical trials report their data. And what we're looking at are the percentage of individuals who remain without disease following vaccination. And they declared that this was not significant protection, so there was no significant difference between the vaccinated and the control group. What was interesting is that when they broke this down by sex, so looking in females and males, what you found was that while the efficacy of the vaccine was not significantly protective in the males, you did get significant protection of vaccinated females compared with their controls. Again, and there is no precedence to think that something would go to market that has a sex-specific effect, that it could protect females even though it showed no overall protection in males. And so while I think that a lot of the differences that we see in adverse effects, in these correlates of protection for males as compared with females, with both the adverse effects and these correlates of protection, in particular these humoral immune responses being so much higher in females as compared with males, I think there are several biological variables that we and others have shown to be very important in modulating these responses. And while I think it is so important to fully understand the mechanisms underlying this, I think that from a policy perspective, the recommendation should be that there be sex-specific application of vaccine design, that as we consider administration of factors like adjuvants that are going to increase the innate inflammatory response, we might want to deliver this in a sex-specific manner, in which males may benefit from this to a greater extent as compared with females. Formulations, doses, could you give females lower doses and have them be as protected as males? Even route of administration, whether we receive vaccines intramuscularly or intradermally, just under our skin, can really alter the adverse reactions, but not necessarily the immune responses that are initiated. So should there be better consideration of altering the way that vaccines are administered to females as compared with males? So I just want to leave you thinking that maybe we need to be treated differently in order to be treated similarly or protected similarly. So thank you for your time.
Thank you very much, Sabra. Thank you for this very interesting talk. So not only the brain, but also the immunologic system works different between male and female. And there is a very strong need of approaching specifically the function of the immunological response in both sexes. But let's now move to a very, very different discipline. Let's now move to psychology. Our next speaker is Brian Nosek. He's the president of the Center for Open Science. He's an associate professor in the Department of Psychology at the University of Virginia. But in 2007, he received an award from the International Social Cognition Network and the Society for the Psychological Study of Social Issues. And he co-founded the project Implicit, an internet-based multi-university collaboration of research and education about implicit cognition. Brian is going to talk about the presence of stereotypes and its impact on education and policy. Welcome.
Does anyone else have a strong urge to wash their hands, or is that just me? I think the only thing that Sabra and my talks have in common is that they're completely terrifying. So what I'd like to do a little bit different is to introduce you to the parts of your mind that you don't have complete awareness or control over, and what implications that might have for how it is we and others engage with the STEM disciplines. So my area of expertise is on the gap between values and practices. What we think we should do, what we're trying to do, what we would like to do versus what we actually do. And what is it in our own mental constraints, how it is we process and understand information and perceive the world, that might create a gap between what we intend and what we do. So what I'll do is in three brief parts. First, I want to give you some experience with not having complete knowledge and control over your own mind based on very ordinary things that our mind needs to do every day. Second, I want to show you how it is that those basic processes that our mind has to help solve problems also have implications for our social perception, what we see as capabilities of other people, how we evaluate others, and then even how we evaluate ourselves. And then finally, we'll hopefully close with how it is that this might have some relevance to the main topics of this meeting. So let me begin by showing you something about how reality and our experience of reality are two different things. Perception is a fundamental psychological process. There is a world out there, and our brain, encased in a skull, has sensory systems to try to get information about the world out there. And those sensory systems need to construct an experience through what it is we take in from our environment, just a bunch of electrical signals, into some representation of out there in order to solve problems with it. But in order to create that representation, our mind has a lot of rules, inferences, assumptions, heuristics, ways of filling in the gaps of information that we have that we're exposed to in order to create that representation. And those rules and assumptions and heuristics may not necessarily apply to what it is that's actually happening out there. So an easy way to experience that is through the McGurk effect. So this is very easy. All you have to do is listen to this fellow make a sound. He's going to say a syllable, and you have to identify what that syllable is. What I want to have happen is everybody to my left, on the right side of the room, don't watch the screen while he speaks. Look down, look away, check your email now, whatever it is you want to do. Just listen. Everybody on the left side of the room, or my right side of the room, watch him while he speaks. I'll play it a couple of times to make sure that you can hear it. Here it comes.
Ba, 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 ba.
I'll play it again.
Ba, 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 ba.
Okay, by show of hands, who heard ba, ba? Who heard da, da? Anybody hear ga, ga? Okay, this should be the terrifying part. So you can do this yourself. Watch him, don't watch him, watch him. And the sound that you hear in your head is going to be different, whether you're watching him or not. And if you can boost the sound a little bit too, it'll work better. Here we go.
Ba, 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 ba.
Do it again.
Ba, 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 ba.
We won't spend a long time describing why it is this works, but the basic point is that you're getting competing pieces of information. The audio information that you hear when you're not looking is ba-ba. The visual information, when I turn the sound off, is what? Gaga. The audio is ba-ba, the visual is gaga, and da-da did not happen. But you hear da-da, and you even see it.
Ba, 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 ba.
When they're together. It sounds like da-da because your mind gets the ba-ba audio and the gaga visual and says, must be da-da. And it's actually a reasonable guess because in terms of the waveform, it's the average of the two. So for sensory integration, it makes sense to make this inference. But you have no experience of making that inference. You have no experience of the conflict. All of that is managed for you because you have lots of processes that happen behind the scenes that manage information coming in and how it is you experience it. And that's great because it minimizes the load on your conscious experience, which is a very limited resource. And you want to have many of these things automated for you so that you can just continue moving forward and processing other things in the world. But they're making decisions for you, and you don't even know that they're making decisions for you. These things work very quickly, and they can make sense of information that's hard or confusing or otherwise without you even realizing that it's doing it. So I'm going to show you a picture very briefly of an animal. And you just identify what the animal is. It's only going to be up there for like half a second, so try to see if you can identify it. Here it is. What was it? Who says frog? Who says horse? Okay, who saw both? Okay, it's both. So now what I want you to do is when I put it back up on the screen, I want you to see the one that you didn't see first. And I'll tell you right now, you cannot do that. You're going to see the one that you saw first. But what I want you to experience is how much longer it takes to see the second one compared to how long it took to see the first one. It was only up there for a half a second. It was no problem at all for you to see one. Which one you saw was random. It's going to take more work to see the other one here. If you're not seeing the other one, rotate your head.
I only see the frog too.
The left side base is the base for the horse, and this is the horse's mane. The right side base is the base for the frog, and this is the frog's head on a lily pad. Okay. The point for our purposes of this example is that it is no problem at all for us to come to a conclusion about what it is we're seeing. Our mind is fully prepared to digest ambiguous information and create an experience and have it be a singular experience. And once our mind has decided on an experience of something, it's very hard to unsee it. We have a default, and we like to retain our defaults because those defaults mean we've solved that problem and we can move on. So once we have an assumption, that's just how we continue to process the world, and it takes a lot of extra work to undo it and see it another way. Okay, one more of these and then a perception, then we'll get to what we're actually supposed to be talking about. So this is an easy way of showing how automatic processes can interfere with what we're trying to do, what our intentions are. It's called the Stroop effect. So the words are totally irrelevant. All that matters is the colors. So what you have to do is keep up with the blue arrow. The blue arrow is going to go down, and you keep up saying the colors that the words are printed in, and try to keep up with the arrow. Okay? Here it goes, starting at the top with green. Ready? Go. Green, blue. Good. Okay, so remember, the words are irrelevant. It's just the color that they're printed in. Starting at the top with red. Here we go. Red. So if you had trouble with the second one, it means that you can read. And you are so good at reading that you can no longer not read. Reading is now obligatory. A word presented to you in English is read. It's not a matter of intent. It's not a matter of trying. It just happens. And that's great. It's super efficient. There's no consciousness involved. The problem is that it's obligatory. If you have a task where something that's now automated is antagonistic to, it's very hard to do that other task because you have a click word and you want to just do it the way you've always done it. And that's read the word. It's right there in front of you. And so when we have things that get automated, it's very useful and efficient for us, but we become slave to them in one way or another. And not completely slave, that's overstating. But here's the last perceptual demo, and then we'll transition. This is a checkerboard drawn by Ed Adelson, who's at MIT. And he drew it to illustrate something important about perception. And he drew squares A and B to represent something in particular. And that is that they are the same shade of gray. The square labeled A and the square labeled B are exactly the same shade of gray. Yes, it's true. Does anyone believe me that they are the same shade of gray? Only the psychologists in the room say, yes, that's true. So I'll try to prove it to you by getting out of PowerPoint and just taking those squares. I'm just going to push the B up to the A. If you need to leave the room, that's okay. Another way to get rid of the illusion is to connect them with that shade of gray. It looks like I've changed the colors of A and B. I haven't. You did. You did by changing your understanding of what the image actually is. When we have the image like this, we understand it to be a checkerboard with a shadow. And we know a lot of things about how it is that that kind of thing looks. And we do a lot of things in trying to figure out what objects are by amplifying edges. At our eyes, everything is just a mush of color and location. In order to figure out where one object ends and another object begins, we need to see edges. And those edges become very important. And so for A, we amplify the edges, which are light squares around it, and A is darkened by comparison. B, surrounded by darker squares, we lighten it by comparison in order to amplify that edge. And so our experience is that they are two different things. But our knowledge is now that they're not. And so there are two important things to take from this. One is, once you know that A and B are the same shade of gray, your perception doesn't change. Your experience still has them as A and B are different. And that's because perception is not subject to reason. You do not get to decide what you experience. That's just what comes up from the activities of your mind. And so it will remain compelling as an experience. And the only thing you have available as an override is your knowledge, is a correction to that experience. The second thing that's very important about this is that the same thing, that shade of gray and that square, can be experienced fundamentally differently depending on the context around it. And there is an important social analogy with this. And it can be illustrated with a classic study by Condrey and Condrey. So participants in this study came in and watched a video of Baby and the Jack in the Box. Jack in the Box, da-da-da-da-da-da. Jack pops out of the box and the baby goes, "Wah!" And they asked people a lot of questions about what the baby's experience was, particularly emotional experiences. What was the baby feeling? Half the participants were randomly assigned to being introduced to the baby as Joan. The other half randomly assigned to be introduced to the baby as John. If the baby, same baby, one video, if the baby was introduced as Joan, people were likely to say that the reaction was a reaction of fear, right? Baby crying when the Jack popped out of the box. When the baby was introduced as John, people were more likely to say that he was angry, pissed off at Jack for coming out of that box when he shouldn't have come out. Right? The video was identical. Right? You ask the participants, did you use gender to decide what emotion that the person was having? They say, what are you talking about? You just said, describe the emotion. That's the emotion. I'm looking at it. That's the emotion. So the experience was fear versus anger, without any knowledge that gender was playing a role in moderating that experience. The gender was the irrelevant surround to what is fundamentally the same thing. And you couldn't convince them that they weren't seeing what they were seeing because experience is compelling. So we are interested in what are the consequences of this kind of knowing. We're exposed to all kinds of ideas, beliefs, stereotypes, things in the world that might be different than our conscious beliefs and values. That stuff gets encoded in our memory. We may not even know that it's there. And maybe it changes the way we see the worlds around us, maybe even the way we understand ourselves. So I want to illustrate one of the tools that we use to try to measure associations that exist in people's mind that may not be consistent with their conscious beliefs or values. And the test is called the implicit association test, and it looks like it's not even going to open for me. Well, that's great. So I may not show it to you. I may just describe it to you. Let's see if I can just control quit it. I'm just not even going to try to play it. So I'm going to tell you how it works, and then you're going to go to our website and try it out and be amazed there instead of here. So the task is very simple. Imagine you have a deck of cards. And instead of 4 suits, 2 of the suits are male and female words. The other 2 suits are words representing science or words representing the arts. Okay? And you have to shuffle up these cards, and you have to sort them out into 2 piles as fast as you can, 2 different times. The first time you sort them, you put all of the male words, the male cards, and all of the science words into one pile, and all of the female words and all of the arts words into a different pile. And we time how fast you can go to sort those out. In the second condition, you shuffle them up again, but now you have to sort all the female words and the science words in one pile, and all the male words and the arts words in the other pile. And what do you find? You find that most people have an easier time sorting when male goes with science and arts goes with female, regardless of what their conscious beliefs are. So these kinds of words. And this is the distribution that we get from our website. You can go, if you search for Project Implicit, you'll find our website. You can try out these tests yourself, and you get individualized feedback. What I'm showing you here is histogram plots of some of the data for this task of sorting science and arts with male and female. And in the darker blue, and further to the right, are people who had an easier time putting male with science and female with the arts compared to the reverse. In light blue are people who had the reverse association, easier time putting female with science than male with science. But what we find is that most people show this pattern, and it doesn't matter what gender they are, and it doesn't really matter what their conscious beliefs or values are. They have 2 distinct parts of mind. One that they don't have complete access to, that appears to be influenced by just the things they see every day in their environments, and another part that is their conscious beliefs and values that they might be trying to have be a basis of their judgments and decisions. So there are many people who have offered ideas about how it is and why it is there are sex gaps in STEM participation. David Galertner offered, for example, this quote: "Women are not being kept out of science by force, so they must be choosing not to enter, presumably because they don't want to, presumably because, by and large, they don't like these fields, or, on average, don't tend to excel in them," which is nearly the same thing. Now, Professor Galertner is known for speaking his mind about a lot of issues about which he is not an expert, but he presents an idea that is not an unpopular one here, and that is that there aren't obvious barriers anymore. If you ask individuals about the barriers they experience, many can describe obvious barriers, but you don't sort of see them in the air in the same way that we used to see them in the air. So the question remains, why does the gap remain? And it's easy if we think that people are just autonomous beings making the choices and having choosing and wanting and liking coming from the wellspring of the soul to think that, well, the soul then just doesn't want it. It's harder to recognize that that culture still imbues the mind, those girls' minds, with what is possible for me, what could I do, and what the perceivers, the stakeholders in the system, the people already there, of looking out at others and saying, is he or she capable for this? Should I go the extra mile? Should I encourage extra here or there? Those things aren't necessarily recognized because we don't even necessarily know that we have them. So here are a few illustrations of how it is these expectations or associations that we may not even know that we have can have an impact on our everyday behavior. One comes from a group at Yale who did a study where they created resumes for a lab tech position in science labs, and gave them to faculty who would hire a person like this for their lab. And they had the same resume, and they just randomized the name at the top, either a male named John or a female named Jennifer. And then they had the person evaluate the resume and give a whole bunch of ratings. So, for example, in this case, if the resume had a male name on the top, or a female name on the top, I should say, they were judged to be less competent, a pretty good effect size, less hireable, and were offered $4,000 less in starting salary. Again, these are not people who would endorse sexist beliefs or say that they don't want women in their labs. In fact, you ask them directly and say, geez, I'm really committed to diversity. I want to have a diverse lab. This is important to me. Nonetheless, those differences emerged. Right? We did research with the data that we've collected on the internet. We run our website in about 22 different languages, have had about 15 million tests completed over the last 15 years we've been operating. And the aggregate data that we have on the gender science stereotype, we organized by which nation we got it from. So what I'm showing you on the x-axis here is the strength of this implicit stereotype, how strongly by nation people associate male with science. Further to the right is stronger associations of male with science compared to female with science. On the y-axis is an international test called the TIMSS, standardized exam given to all 8th graders in 35, in this case, different nations. And what we found was a relatively strong relationship with the strength of the implicit stereotype in that nation and the size of the sex gap in that nation. So the TIMSS scores, 0 is no difference between boys and girls in 8th grade on this task. Positive values mean boys did better, negative values, girls did better. And so nations that have high implicit stereotypes also have higher performance gaps. And this is correlational data. We can't identify causation, but it's likely, I think, that it's a bidirectional one. Right? As soon as a stereotype exists, that has impacts on people's engagement and performance. As soon as you see differences in engagement and performance, that cycles back and influences the stereotype. See, everybody's different. We knew it. These implicit stereotypes also have impact, or at least are related to, people's choices about what kinds of careers they pursue. So what I'm showing you here again on the x-axis is that strength of that implicit stereotype. 0 are people that were equally fast putting science with male and science with female. Positive scores are people who put science with male more quickly than science with female. And on the y-axis is the probability that they had chosen a science major. So for men, the stronger their association of male with science, the more likely they were to choose a science major. For women, the weaker that association of male with science, the less likely they were. The weaker it was, the more likely then they were to choose science as a major. So at the 0 point is pretty close to where these two lines intersect, meaning equal likelihood of choosing a science major with no stereotypes in mind. This isn't just in major choice. We see that these implicit stereotypes are related to lots of things that are consequential for STEM engagement. So your attitude, how much you think that math or science is good, is predicted by implicit stereotype for women. The more they have the stereotype, the less they think math or science is a good thing. Explicit stereotypes about science don't predict as well. Identity, how much you think of that as something that is like you, that you identify with, also predicted. How confident you are, also predicted in a negative direction. How much you expect to participate in the future, how much you say that you are good at this particular domain, and then your actual performance as gauged by the SAT. So there are a variety of different factors that are at least associated with the presence of these implicit stereotypes that people don't even necessarily know that they possess. And it is the case that these aren't in full existence right when we are born. There does seem to be, at least in cross-sectional data, a trend for these stereotypes to be increasing over time. We don't know if this is a function of historical patterns, the world is changing, or if it's an actual developmental trend. Probably both play a role, but we don't have sufficient data to determine that yet. But what you can see here is at the x-axis is the age of the respondents at less than 13 through 50-year-olds, and on the y-axis now is the strength of that implicit stereotype. And younger people have weaker implicit stereotypes about science than older people do. And some of our colleagues at University of Washington have looked at this among 6, 7, 8-year-olds and shown that they don't yet have the stereotypes implicitly, but then they emerge in early elementary and middle school. Probably close to time. Okay, so I'm not going to talk about what we can do about it. What you should instead do is go to Toni Schmader's talk tomorrow. She's going to talk a lot about that. And I'm sure there are many other talks about what to do so that we can make sure to get to the other talks. So instead, I will invite you to take a look at my colleague's book, Blind Spot, Mahzarin Banaji and Tony Greenwald, all the co-founders of Project Implicit. And this book goes through the evidence about implicit bias. And then visit our website, Project Implicit. You can try the test that didn't run and see what you get. So thank you very much for your attention and time.
Well, being a molecular parasitologist, as I said before, it's hard to me to find something smart to say after this. The only thing I can think of is ba, ba, ga, ga. Thank you very much, Brian. That was a wonderful talk.
That was.
Okay. Let's now move into the social sciences, and we have the fortune to come with Professor Ruby Heap from the University of Ottawa in Canada. Ruby is a professor at the Department of History at the Ottawa University. Dr. Heap specialized in the history of women in engineering, promoting the view that engineering should be an inclusive profession that values, supports, and celebrates the contribution of women. Welcome, Ruby, and the ground is yours.
I want to react, if you allow me, for 1 minute to your talk. Historians of science and technology, at least in Canada, many of them support that view that women are free to choose what they want to study. And if they're going to the life sciences in greater numbers, it's a conscious decision that meets their needs. So I have to argue with a lot of my male colleagues about that claim that, you know, there are no more barriers, everything has been resolved, and so forth. The second thing about science and engineering also, there's a cultural element tied to it. I was just going to say that when I was a young girl, I was raised in Montreal in a Catholic Francophone family, and I attended a convent. And I wanted to be an engineer. This would be in the 70s, 1970s. And the nun came to see me and said, well, you know, engineering is not a proper profession for a young Catholic girl. Architecture is fine because there's the arts element attached to it, but certainly not engineering. And I went back home, told this to my parents, and of course they obeyed the church almost blindly at the time. And they said, well, yes, probably they're right. So I never became an engineer, and I still regret it. But what I want to say that it also affected men in Catholic Quebec who wanted to be engineers because it was not considered as privileged a profession, or if you want, high status profession, as the liberal, what we call them, professions, where that is law and medicine, where, you know, people wanted, you know, males wanted to become lawyers, and doctors, engineers, less so. So there's the status attached to a profession that's also culturally shaped. So Thank you for that great talk because it sort of stimulated some insights on my part and some thought. So thank you very much, Isabelle Blain, for inviting me to this great summit. I did attend the one that she talked about this morning in 2010, and it was a great meeting, and people are always so welcoming in these meetings. So I'm very glad to be here. I'm a historian, but I do history of women in science and mostly engineering. So the title of the talk that you see in your book was the first one on the top, but I decided to focus on a specific theme, which is the contribution of Canadian women engineers and scientists to the shaping of policy from the 1970s and the 2000s. So I'm going to teach you sort of like a history lesson here because I feel that's very, very important to know what our predecessors have done and never to forget what they've realized, because without their contribution, we would not be here today. So just a little bit of information on my background. I do specialize in history of higher education and the professions. I've been closely involved in women's studies at the University of Ottawa. I'm part of this group called Education and Research Institute of INWES, the International Network of Women Engineers and Scientists. You may know of it, and part of a research team working on a vast study on engineering and education in Canada. So why does history matter? I'm talking to you mostly as scientists and engineers, and I just want to quote two of my favorite historians. Gerda Lerner, who's a famous US historian, wrote several groundbreaking books, who argued that women's struggle to comprehend their own history lies at the heart of their ability to envision a world in which they are full participants. If you don't know that you've been in history, that you're part of history, well, it will be, very difficult for you to fight for equality. And Marion Ainley, who just passed away a couple of years ago, who's one of the pioneer historian of women in science in Canada, she was trained as a chemist, moved to Montreal, and then discovered history. And it is really still one of the, the most prominent historian of women's science in Canada. And she just published a book. After her passing away, her colleagues published her book. It was in a manuscript form. And one passage I think is very important for all of us here today. She said, more detailed women-centered research has revealed that many women studied and worked in science, whereas the traditional textbooks never talked about them, and they achieved recognition. Some of them were quite famous in their own time, but the textbooks, the histories that we have, never mentioned this. Although, and this is a very important thing that she mentions here, although their professional lives followed different paths, both from their male peers and even from each other. So we cannot talk about a general experience, historically speaking, of women in science and engineering. And that's what her book really tries to demonstrate. It deals with actually women academics in English Canadian universities who taught science in faculties of science. And actually, after I read her book, and I knew Marion very well, she always complained about the lack of sources to write about the history of women scientists in Canada. That is, the lack of archives, personal papers produced by women scientists and engineers themselves. So in her memory, actually, I've set up this project of a workshop with my colleague from the University of Ottawa, Catherine Mavry-Plis, who's one of the Enchurch chairs for women in science and engineering. And we're inviting the chairs, all the chairs, past and current, to come at the workshop to try to convince, of course, women scientists and engineers in Canada to keep their archives, their personal papers, because without that, we will not be able to write those stories that we're talking about. It's important that we know about their history. So hopefully we can, and we always have big dreams, and the goal would be eventually to build an archive of women scientists and engineers in Canada, where, of course, researchers could come and conduct their research on women's science and engineering. No such thing exists at the moment, and what I'm afraid of is that many women scientists and engineers have already thrown away their papers thinking, this is not important, that's one part of my life, nobody will be interested in that. That certainly is not the case. So hopefully we will be able to convince many at the workshop and after that to keep their papers. So the presentation I will do today is based on one of my current projects, which is entitled The Problem of Women in Science and Engineering in Canada since the 1970s, the construction of gender debates, interventions, and policy. So the main, as historians, we're talking, of course, here about evidence-based research. Historians need to provide the evidence to write about their topic. If there's no rigorous evidence, nobody will believe you. Let me tell you, that's what we're trained to do, is find the evidence in those papers and archives I was telling you about. So the issue for me was that when I started to be interested in women's science and engineering in Canada, I couldn't find anything on them in the current historiography that dealt with women, with engineering, the history of engineering, and B, with the history of science and technology. So I had to go back in the archives, dig them up, pick them up, and eureka for me, I started to find a lot of women, and you'll hear about them. So the project that this is all tied to is a project that wants to examine when we started to talk and discuss and conceptualize what we call the problem of women in science and engineering. So it's important to go back in history to place the making of this problem in its historical context, and then to develop a general framework in which to map this process, different phases and its various manifestations over time. So no such study had been done in Canada. So I'm going to go quickly over the framework here and focus on the second point in this talk, is to identify the main groups and actors that were involved in the making of this problem of women in science and engineering. And of course, you know, we still talk about the problem today. So what I want to provide you is some bits and pieces of the answers in the Canadian context on why and when we started to use that concept. And as I mentioned, I have several goals in pursuing this project with my research team, is to fill gaps in the Canadian scholarship, what I just mentioned to you, where you don't find any women at all in studies, books, articles on science and technology policy. It remains very gender blind. Also, what I want to do is encourage historians of women to examine the evolution of Canadian public policy by incorporating also science and technology. Women historians in Canada, at least, tend to focus almost exclusively on social policy, health policy, and family policy, which is understandable, but they have omitted the science and technology policy sector. And I want also to insist on the third point, is to encourage comparative studies that would involve Canada. I think comparative studies between countries are very important, and certainly I would like to see more of them done that would include Canada. So the findings, I'm going to give them to you right away, are very simple. Is that I found out through the research that the individual and collective activism of women scientists and engineers in Canada does constitute a key chapter in their history since the 1970s. And this chapter of their history also provides important insights into the history of the women's movement and of science and technology policy in Canada. So, of course, ideally, I would want to see this study, you know, being integrated in these general historiographies, that is, of women, of the women's movement, but also science technology policy in Canada. So, what are the historical roots of what I call the women's movement in Canadian science and engineering? And I must say I borrow the concept from Margaret Rossiter, the great historians of women in science in the United States, who in volume 2 of her famous trilogy said that she did found that there was such a movement in the United States starting in the late 60s and early 70s. And I was curious to see, and I told Margaret, because I've interacted with her in the past years about this project, that I found something quite similar in the Canadian context. So that's why I use the same, of course, expression here, the term rather that she's using. So what I found is that there was a first generation of activists in the 1950s and 60s in Canada that will inform those who will come later. And two of them come out. One is Elsie Gregory McGill, you may have heard of her, who was a professional engineer, and Ursula Franklin, an academic who taught for many, many years at University of Toronto and the Faculty of Engineering. So Elsie McGill, put the picture here, she is, and you'll see why. Elsie Gregory McGill is considered Canada's first women engineer. She graduated in electrical engineering from U of T in 1927, and she's the first woman aircraft designer in the world. She became so famous that they had a cartoon based on her achievement. She was called the Queen of the Hurricanes. She designed an aircraft for the British Army during World War II, and she was called Queen of the Hurricanes, as the title of the cartoon indicates. And what you don't know about Elsie here, and we talk about disability, she was struck with polio at a young age and walked on crutches for the rest of her life. Actually, went on her own plane with her crutches and to see, of course, to test her own design. So she's a very good example, not only as a pioneering women in engineering, but as a disabled person who was able to pursue a very successful career. So I always mention her to my students, mentioning both the gender, but also her status as a disabled person. And Elsie was she expressed her feminism very early on in her career. She was a member of a famous Royal Commission on the Status of Women in the late 60s, and everybody recognized that she was the only feminist on that Royal Commission at the time. Here's another picture of her at the time where she was working during World War II to design the plane. So the other person I want to mention is Ursula Franklin, who I've been interviewing during the course of the summer, who's really an inspiring role model to many women engineers and scientists in Canada today. Career at U of T, she was a pacifist, came from Nazi Germany. She was in prison in camps, managed to come with the family. And was one of the first feminist critique of technology and engineering in Canada that came from science and engineering. And she has a famous quote that you can find in the book that you see here. She always urged her female students, please don't check your feminism at the laboratory door. Because many of them were worried that if they pursued higher education, especially at the graduate level, that if they happened to be feminists, that would not help them at all. Far from it, it would act as a detriment to their career success and their career. And she said, you should never do that. And she keeps telling me that she continues saying this to the young women who come and visiting her. So these two women do indicate that you did have activists in the Canadian context early on, but the problem of women in science and engineering really started to be conceptualized in the 70s and early 1980s. And the women's movement played a very critical role to that effect. I talked about the report of the Royal Commission on the Status of Women, which urged basically young girls to enter all masculine professions in the name of equality. And at the same time, following the report, the 1970 report, you see the women's movement that begins to institutionalize itself in the 1980s, and that will support this campaign for equality of men and women in all professions. I want to mention the femocrats. Maybe it's a term that you've never heard before. It refers to, and we use it all the time now in feminist science and technology policy studies, it's those feminists who happen to be bureaucrats in higher levels of government. And I started to identify them and to interview some of them for my own research, and there were quite a few of them in the Canadian federal government at that level, federal level, starting in the 1950s. They were in the Women's Bureau. I know there was something similar in the United States. So these are women who exerted quite a lot of influence because they were occupying these strategic positions at the federal government. And the best example is those that were at Status of Women Canada. It still exists today. And in the 1980s, they achieved even more influence in helping, of course, this campaign to bring more girls into engineering and science. And they're the ones also to help promote these concepts that you didn't use beforehand, such as sexism. You were talking about stereotyping. Well, we started to talk about that at that time. Inequality of opportunity and segregation in the workplace. So these are all words, concepts that appeared with the second wave women's movement. And also, they started as well to promote, of course, human rights and what was called at that time the just society. So what's fascinating is many young activists now that I meet talk about social justice and the role of engineering in promoting social justice. Well, they were talking about achieving a just society at that time, and one of the ways, the means would bring the young girls and women in those masculine professions. So the road to mobilization amongst, that is, the community of women scientists and engineers has to be related to a large degree to the impact of the women's movement, because many laws and measures were adopted to break down at least the legal barriers to equal access to education and employment opportunities. And a closer look at the situation in engineering illustrates the change that you start seeing within the younger community of women engineers at the time, because I studied engineers more specifically. So you see that in numbers. You do see the numbers, I'll show them to you later on, of enrollments increasing all over the country starting in the 70s. It's a steady and continuing increase. But what's interesting, a survey was conducted in the early 1980s by Dormer Ellis within the community of women engineers at a time. There were not that many of them, but they all responded, or almost all of them responded. And they started expressing the need to mobilize themselves and to create their own associations. And many said, yeah, if there were associations like this, I would certainly join, because there are issues that I want to discuss with my colleagues. So the result has been that starting in the 70s and 1980s, and I won't go through all of them, but you can see by the sheer number that there was this collective mobilization of women in science and engineering through all these organizations that were created. So I want to mention the last one, that was created in 1987, which is CC West. I'm sure many of you know of it. And also, I want to mention the WISEST, because we have Margaret Armour here, who was one of the founders of, yes, you were. So I want to acknowledge, and Margaret is still here. I think we should applaud her, absolutely. So she's part of that generation of pioneers, and I want to underline her great contribution to that. Must have been a very exciting period. It was, eh? Okay. So the links with the second wave movement there, just to finish on this, because it's important to mention this. There's been a lot of course, debate about the links between women's science and engineering and feminism, tensions between the groups. What my research has showed so far is that, like I mentioned, the femocrats in the government, federal level, provincial as well, did support many of these activities, providing funding, for example, to some of these associations I just mentioned. And one leader that I want to mention, because I'll come back to her very soon, is Claudette Maquet-Lassonde, who was a prominent engineering activist, graduate from l'École Polytechnique de Montréal, and she openly credited the women's movement for creating, and I quote her, a wave of awareness of women's ability to achieve. And there were, at the time I mentioned Ursula, women scientists and engineers in universities that were faculty members who started to develop feminist critiques of science and engineering. Maggie Benston was one who became very influential. She was a computer science professor. Roberta Murat from Université Laval, and Karen Messing, who came from UQAM, amongst others. So there were links between the groups. That being said, we had a backlash against the women's movement and feminists in the 1980s in Canada, a fairly intense one that really hurt institutional feminism at the time, starting with budget cuts and programs that were closed. So, of course, that didn't help the relationship between the two. There were other issues also involved, but also the fact that activists in science and engineering, those I interviewed, many of them said it was difficult. You know, we were in a very strong masculine culture, and you know, you can't change things overnight, so we had to be careful. We were strategic, although they agreed that they supported the main goals of the women's movement, equality of opportunity, fighting sexism, and so forth. So these were difficult times for the women's movement, and of course, this led to maybe certain distance being taken with other women's movements in Canadian society. Now, the other important element in the story is that women scientists and engineers became very important for the federal government because they were supposed to fulfill, and I put manpower because language is fascinating, is at that time you start saying to women, oh, we need you to fill, you know, this great gap that we have for skilled labor, and they use the term manpower. So they see the contradiction at the time, but I can say that as you go through the 1980s, and certainly by the 1990s, you don't use manpower anymore. You're talking about labor shortages, human resources, so you substitute new words. So that's what's so fascinating about this story, is to see the change in the language that's being adopted by politicians and the government in Ottawa. So this is where women science and engineers will really mobilize themselves to, of course, engage in this campaign of the federal government to develop a national science and technology policy in Canada. And it was adopted in 1987, and that was a great moment because at that time, women in STEM became a key component of the government's envisaged national system of innovation. And I want to spend some slides talking about NSERC. We've heard about NSERC this morning. Isabelle Blain, of course, talked about what they're doing now. But I want to reiterate the fact that NSERC has played a key role in the promotion of women in science and engineering, and was a strategic player in the development of Canadian science and technology policy. And we've mentioned that the chairs, but there was one national chair that was created in 1989, the National NSERC Northern Telecom Chair for Women in Engineering, and it was a unique model at the time, the first of its kind in the world. And it was a major policy statement because it involved universities, it involved the private sector, it involved the government, and it involved the granting agency, which was NSERC. And I just want to give you a little example how women can make change. Claudette Maquet-Lassonde, who I just mentioned, played a critical role in the creation of this national chair. And just to see, I want you to read the bottom paragraph to understand how she played her cards extremely well. So she happened to hold a senior position at Nortel that became the private sponsor, industrial sponsor of the chair. She had been appointed the first female vice president of the board at NSERC at the time. And she was also sitting on an advisory board on science and technology that was just established by the conservative government and chaired by the prime minister. So she was able, of course, to use all her contacts and an influence in these diverse positions that she was holding to promote and push for, yes, the creation of this chair. So we talked about the Montreal massacre on December the 6th. I'm going to go quickly. But one of the main consequences of this massacre is that it acted as a catalyst for change. And I quote Ursula Franklin again, who writes about this. She lived through that tragedy. And she said, it finally became possible to speak publicly about the chilly climate, about bias, about sexism, misogyny, and patriarchy, something she said that was very difficult to openly discuss before. So there was an aftermath that was positive, that is that a lot of programs and measures were adopted to reach young girls, K-12, and also to support women faculty and students in universities. What I want to mention about NSERC as well, and I go back to NSERC, is that it really played, again, a pivotal role in promoting a new scientific and engineering culture in Canada. So I'll go quickly. I just want to mention a report of a committee on women in engineering in 1992 that was supported by NSERC, where this is where you see the change in the way you understand the problem of women in STEM in Canada at the time. So more than just numbers, what it says is that it's not enough to bring more women in. You have to transform the learning and working environments and support and appreciate women engineering and students and engineers. That is, you have to transform the environment and culture, because that's the only way you're going to retain women in science and engineering. And another task force that was supported by NSERC that I want to mention again, because we talk a lot about research at the summit, we've been talking about this since this morning, is that already at that time, NSERC was preoccupied about the status of women in science and engineering research in Canada and set up this task force to examine what we could do to, of course, engage women in research and make sure that they would succeed. So then, NSERC was really a key player again in fixing this new agenda for the 21st century. That is, no longer sufficient to bring more women. You don't try to fix women. That is, oh, you become one of the boys, it's all going to work out. You try to fix the institutions by attacking the chilly climate. And this is when the 5 regional chairs for women in science and engineering were created in 1996. Of course, they're still here today. I think we've reached the 3rd cohort in some cases, and they have a very broad mandate. 2 things that are important in the 2000s, I finished with the early decade of the new century. is that Women Scientists in Engineering Canada went global by creating the International Network of Women Scientists and Engineers. It was launched in Ottawa, Canada in 2001. And Canada, as you may know, has two large cultural and cultural communities, Francophone and Anglophone. So the Francophones in Canada decided to create their own association of women in science and engineering in 2002. So I just want to go fast. I was going to show you some of these. And by the way, these great charts that I can't show you are from the NSERC 2010 report on women in science and engineering. It's available on their website. Great data that they've produced. Now, my concluding remarks, why are women in science and engineering still controversial after more than 30 years? And I'm quoting from Sue Rosser in her latest book, Breaking into the Lab. I had the chance to work with Sue when I was doing my sabbatical at Georgia Tech, and we had very fascinating conversations, and I thought controversial. Of course, you know, it's after the Lawrence Summers crisis that, you know, she talks about the controversy. But as Sue mentions, many of the past issues are still here today amongst us. But they're in a different form. You talk about unconscious bias instead of blatant discrimination as you did back in the 1970s, but the problems are still there. They can be expressed in a different language. Again, for me, language is very important. Work-life balance. They didn't use that term in the 70s and early 80s, but you know there was an issue. Should I have children? The glass ceiling, gender discrimination. So words have changed, but many of the issues are still here. Now, I asked, do we need to reconsider what has been done so far? Now, historical research, and I'm a historian, I'm going to leave you with some thoughts as a historian. My research and those of my colleagues points to a key challenge is the complexity of women in STEM. You know, women in STEM is like a homogeneous category, but you have to break it down. And I'm just going to give you some examples. The profiles of women in STEM. The intersection of gender, yes, but with categories of race, ethnicity, religion, disability. Elsie McGill, you could have addressed this issue back then. Sexual orientation. The lives of women in STEM are very different from one to the other. That's what Marian Ainley explains in her book. It ends in the 1980s. Complexity of the institutions we all work in, schools, colleges, universities, private, public sector, very different. Of the cultures in STEM, I've interviewed a lot of students and profs from various disciplines, sub-disciplines in engineering, and that came out very clearly. They're very different. And that's, for me, it's very important. There are different masculinities and femininities within the community of science and engineering. I was talking about one of the boys. Well, some women don't want to be part of the boys. So the sameness and difference dichotomy, you know, creates a lot of complexity. So my challenge to you, and I know it's not easy, is that, you know, how can we develop policies and action plans that will take this complexity into consideration? And somebody was talking about internationalization of universities this morning. Ottawa U, of course, also has embarked on this. Don't forget that means that we're seeing more and more young women from the Middle East, from China, from Iran, in our case, in Ottawa U, who are coming to study, mostly at the graduate level. I'm Associate Vice President of Research now, and I see a lot of them who come and see me who have difficulties of all sorts. We have to consider them as well. They're not just numbers saying, oh, we've reached X% of international students, bravo. Is that many of them, you know, are encountering difficulties when they move here related to all sorts of issues. So that's my message also when we talk about internationalization. They're human beings and women who need our support. So I will finish here. Thank you.
Thank you, Ruby, for this very inspirational talk. So we're supposed to provide a series of conclusions on the presentations, on the papers, and this is going to be very difficult. We need to investigate not only the gender or sex issues on the immune response, the perception, but also the production of culture. We also need to study the participation or involvement of women on STEM, on science, technology, engineering. There are many, many unknown details. I have learned a lot along this session. I don't know who conceived the organization of this session, Dr. Ward, but the cocktail you conceived was wonderful from my point of view. Leaving the possibility of reaching conclusions, maybe we can open the ground for a small number of questions and comments. So any of you would like to say something? We have one there.
Hear me?
Yes.
I'm Carol Muller from Stanford University. I thought it was a great panel. I especially wanted to thank you for the word femocrats in your very interesting talk, Dr. Heap. It reminded me of Deborah Meyerson's tempered radicals concept, which could be expanded beyond feminists to other progressive action. Professor Nosek, your story reminded me of sitting last March in a meeting hearing Daphne Hoel from Israel make a very interesting presentation about her work on the science of sex differences in brains and the extent to which no scientific research that's well done has really pointed to anything that could explain some of the differences in behaviors and occupational segregation and those sorts of things, popular literature notwithstanding. But I particularly wanted to ask Dr. Klein a little bit more, Professor Klein, about the extent to which people might be trying to unpack those very interesting differences you are finding, particularly because I think there's a danger of assuming they're all biological and somehow innate in origin, and also in terms of stereotyping sex differences that are identified without really clearly communicating that we often have a spectrum. And so trying to understand those findings a little bit more deeply in terms of some of the influences, so that when we say, well, we found that, you know, women are more likely to respond in one way or men in another, we aren't inadvertently doing more stereotyping, or maybe finding things that would correlate even more strongly with other characteristics beyond gender. So I wondered if you could say a little bit more about that.
Okay, so I'm going to make sure I understood the question. You're asking how we could better either collect or analyze data so that we avoid stereotypes when defining or interpreting data of differences in responses to vaccination?
I think it's especially about the interpretation. Just to give you an example, and I don't know if it's relevant to the work you're specifically doing, but I know that I believe I understood the findings correctly, that there's some interesting differences in the blood pressure of African Americans, which is an ongoing health problem in the US, that aren't found in people with the exact same genetic makeup living in Africa, which suggests it's environmental versus biological.
Okay.
So I'm wondering about biological factors that might be contributing to the results you mentioned.
Okay, so I can't off the top of my head, think about how a cultural or environmental factor would contribute to why your immune response would be higher to a vaccine in one population over another. And do you want to stand up and counter that? No, because your look
I'd like
is...
to ask all the scientists in this room, because I don't have a background in that
Yeah,
area. But
so
I guess I was
think-
just thinking that from my understanding, immune systems are actually very prone to fluctuations based on environment and environmental influences. And if you live in societies where certain groups live with greater stresses than others for a whole variety of reasons, I would think that might affect their
Yes, that
immune
absolutely
responses.
could. How that would translate into higher immune responses in females as compared with males, I'm not certain.
Okay, another question or comment?
There we go. Needed the green light. My name is Zina Sharman, and I'm from the Canadian Institutes of Health Research, Institute of Gender and Health. So thank you, Dr. Heap, for giving me the term Femocrat, because I am a Femocrat, and I am a third-wave queer Femocrat, which I mentioned because it also does inform my perspective on the work that I do. But now I have a good, catchy name, which is so handy. The question I want to ask is, one of the key things we're doing at our institute, which is a research funding agency, is not only thinking about who does science, but also how we do science. And one of the things that I am really working on within our institute, and that I would love to hear your perspectives on, and certainly Dr. Nosek, I think really, especially from you, is we're interested in changing scientists' perspectives across the full spectrum of health research, so from the biomedical to population health, to get scientists to think about taking up sex and gender. And I think that there are other forms of biases, other constructions of scientific ignorance, conscious or otherwise, that are at play there. And I would be very keen to hear the panel's perspectives on how you think we can not only change perspectives about who does science, but how we do science and why sex and gender matter. Thank you.
I don't think I have a great answer, but what I can say is that this is a weird way to start it. I'm on leave from the university in order to start a nonprofit called the Center for Open Science. And this is an organization that's aiming to do exactly as you say at the very general level, change the way we do science so that it is not, and the incentives right now are structured entirely toward publication. Publish as many times in the most prestigious outlets possible and not on accuracy. Make a very prominent, provocative claim, don't bother to replicate it because replication doesn't matter, and then it will survive and you win the game, as it were. So it is very relevant, not just on sex and gender topically specifically, but on what are the incentives that scientists operate in order to succeed and thrive in their disciplines. And sex and gender isn't as valued within one's disciplines, but to the extent that science can be more open in the sense of, both in the sense of open to seeing transparently what's being done, but also open in terms of inclusiveness, then fields that aren't yet as valued can be valued more easily because anyone that is interested can pursue. That's not quite getting at it, but that's
Okay,
good.
two more questions and comments. One from the right wing and one from the left. First, the
Wow,
right
my
wing.
family will be surprised. I've never been called right wing. My name is Sandra Mazer. I'm chair of the Women in Cell Biology Committee of the American Society for Cell Biology, and I'm also professor at Mount Sinai School of Medicine, where I head our Office for Women's Careers. And I just wanted to point out to Dr. Heap that there is currently an exhibit in New York at the Grolier Club, which was written up in yesterday's Science, today's Science Times? Yesterday's Science Times, that was Tuesday, right? About, it's called Extraordinary Women, 400 Years of Science, and of Women in Science and Medicine, and it is exactly what you're talking about. The historical effects, it's marvelous because it was put together by bibliophiles who've been collecting this, and it ranges over 400 years. You had to die to get in. So the last person mentioned is Rita Levi-Montalcini, but it is terrific, and if any of you can get to New York or get the catalog, I think you will find it exactly what you're looking for in terms
Where
of
is it held again?
Pardon me, it's at the Grolier Club, which is on East 60th Street in Manhattan. I'll be happy to give you the contact information for the curators of the exhibit.
Wonderful. Thank you. I know
Until
the
November
Society
22nd.
of Women Engineers has done also a great job. Thank you so much, and I will definitely look into it. But I just want to add to that, that SWE, the Society of Women Engineers, if you go on their website, they've done a terrific job in they have an archives actually at SWE in Detroit. It's Wayne State University, I believe. So there are a lot of great initiatives that have been taken in the United States that are a source of inspiration for me, and hopefully we can follow in your footsteps. Thank you.
Thank you. Florence Hasseltine, founder of the Society for Women's Health Research. And one of your great femocrats in this room is Mary Clutter, who's sitting in the middle, who, when she was at NSF, put in a policy that you could not have a conference unless it was balanced. And that actually turned out to be a sea change in a lot of the science communities, because at that point they couldn't say they couldn't find them, because of course, even though they didn't grant them in proper proportion, they were granted. So Mary's right there in the middle, and I'm embarrassing her. But Dr. Heap, I wanted to also, as Carolyn pointed out, there is the same history of women in medicine in the United States had a problem. Mary Roth Welch in the 70s pointed out that she couldn't get any other histories other than Elizabeth Blackwell. And so they started a program of archiving women physicians. And you may be aware of it?
Yes, I am.
Oh, okay. And I just hope that Joanne Murphy's coming to your conference.
Okay, well, I'll...
Because she's the archivist.
Actually, it was one of the first examples of great initiative that was put on my table, was the SWE and the History of Medicine, Women in Medicine.
Yeah, thank you.
Thank you.
Sorry, but we need to finish this. Thank you to the speakers, thank you to the organizers, and thank you all.